This is Mrs. Palmer-Quay with the third video for Module 4. In this video, I want to talk about balancing chemical equations. Chemical equations are the way we describe a chemical change, and they are arranged with reactants, the raw materials of the chemical change, on the left, and products, what is being made during that change, on the right. There's a little arrow in the center, and that is telling you that these reactants yield a certain product. Often a chemical equation provides details on the physical state of the reactants and products, so you will see little letters in parentheses, S meaning solid, L meaning liquid, G meaning gas, and AQ stands for aqueous or in solution. Your chemical equation, when balanced, reveals the ratio of reactants to products, how many reactants are needed to produce how many products. And we can actually say a chemical equation as a word problem or as well as the formulas. You will be working more with the formulas than with the words here at the beginning of the class because you don't know the formulas for some of the names that we will be using. In order to build a balanced equation, the process you need to go through to balance your equation, you first start with your skeleton equation. For example, our word equation tells us that hydrogen gas plus oxygen gas combine to form liquid water. So we write that as hydrogen gas, and note that hydrogen is one of those homonuclear diatomics that you should be memorizing, that in the elemental state, hydrogen exists as a molecule, as two atoms of hydrogen bonded together, as does oxygen gas, so that's another O2, and you know the formula for water of H2O. So this is the skeleton formula. It is not balanced yet, but it has the chemical formulas for the reactants and the products. Another example would say that solid carbon and hydrogen gas combine to form methane. Methane is an organic molecule made up of carbon and hydrogen, and they have their own names. The formula name would be carbon tetrahydride, but most scientists just call it methane. So we have solid carbon plus hydrogen gas giving us methane. This is your skeleton equation. You have the formulas in their correct form, but the equation is not balanced. So the next step is to count the number of atoms of each element in the reactants and the products side. So over here on the reactants, we have 2 hydrogen and we have 2 oxygen. On the product side, we have 2 hydrogen, but we only have 1 oxygen. So after you count, you see are they the same or are there some things that need to be balanced. You balance the element one at a time by placing a coefficient, a number, in front of the formulas, just like you've done with your variables in algebra. You've got coefficients in front of x's and y's. Here you're putting coefficients in front of atomic symbols. If possible, start with an element that only appears in one formula if you've got a more complicated equation. This equation is a little bit simpler than that. So let's start by looking at oxygen. We have 2 oxygen on the left and only 1 oxygen on the right. Now we know that whatever goes in has to come out, that nothing is created or destroyed. So if we have 2 oxygen going into this reaction, we have to have 2 oxygen coming out. And if we have 2 oxygen coming out, that must mean we have 2 molecules of water here, because that would take up 1 oxygen on one molecule and 1 oxygen on another. So we've taken care of the water. Taken care of the oxygen in the water, but then if we look at the hydrogen in the water, if we have 2 molecules of water, then we actually have 4 molecules of hydrogen. So in order to have 4 molecules of hydrogen on the left, we have to put another 2 in front of our hydrogen gas. And now we have a balanced equation, that we have 2 molecules of hydrogen gas plus 1 molecule of oxygen gas, giving us 2 molecules of water. All of our atoms are the same on the left and the right. The equation is balanced. Now let's do the methane equation. Remember, we have solid carbon plus hydrogen gas giving us methane, and this should be gas here. I missed that. First you want to count your atoms. So we've got 1 carbon and we have 2 hydrogen here on the left, and on the right we have 1 carbon, and we have 4 hydrogen. So looking first at the carbon, we see we've got 1 on the left and 1 on the right. There's no problem there. We've got 2 hydrogen on the left and 4 hydrogen on the right. That needs to be balanced. We need to have 4 hydrogen on the left. In order to have 4 hydrogen, we have to have 2 molecules of hydrogen gas. So we need to add that coefficient of 2. So our final equation is balanced, where we have 1 molecule of carbon plus 2 molecules of hydrogen gas, giving us 1 molecule of methane. The same number of atoms of the same elements on the left and the right side of the equation. You want to be careful to only add coefficients to your equation. Never change the subscripts in a chemical formula that you know is correct. So instead of saying, well, I have 2 hydrogen and 2 oxygen, there must be something wrong with this water, let's just put a 2 on the end. No, that's not how it works. In fact, what you've done here is made hydrogen peroxide, not water. So never change the subscripts on formulas when you know the chemical formula is correct. Only add coefficients. Also make sure that all your coefficients are in the lowest possible ratio. Say you went through and did the problem for methane and you ended up with having 2 carbons and 4 hydrogen gas, giving you 2 molecules of methane. Well, this is correct, but it's not in the lowest possible ratio. You need to simplify your problems just like you do in math by making those coefficients down to the smallest possible number. Let's work through another example. Ammonia combines with copper 2 oxide to yield copper, nitrogen, and water. Ammonia is another one of those chemical formulas that you just are going to have to learn. It's been around a long time, and it stands for NH3, nitrogen trihydride. That's ammonia. Ammonia and copper 2 oxide, we'll get to that soon in your textbook. The 2 tells you what the charge is on copper so that you know to write it CuO as the formula. And it will give us solid copper, Cu, plus nitrogen, another one of those homonuclear diatomics, N2, and water. So this is our skeleton formula. We have it written out, and now we need to count atoms. So we see that on the left-hand side of this equation, we have 1 nitrogen, 3 hydrogen, 1 copper, and 1 oxygen. On the right-hand side, we've got 1 copper, 2 nitrogen, and 2 hydrogen, 1 oxygen. So what are we going to start with? We want to start with something that is the different from one side to the other, because we know we're going to have to make some kind of change. We have 1 nitrogen on the left and 2 on the right. So if we make this 2 nitrogen by adding a 2 coefficient in front of our ammonia, then we are changing our hydrogen over here. We are multiplying it by 2, so instead of 3 hydrogen, we have 6. So after we've figured out the hydrogen on the left side, let's go over to the right side. We only have 2 hydrogen over here normally on our skeleton equation. So if we want to make that 6, that means we have to put a 3 in front of the water to make us having 6 hydrogen, but that also then makes us have 3 oxygen. So then in order to have 3 oxygen, bouncing back over to the left-hand side, in order to change this to a 3, then we have to add a coefficient of 3 in front of our copper oxide, which makes us have 3 copper, which means we've got to add a 3 over here on the right-hand side so that everything balances. So let's count it. We've got 2 nitrogen on the left, 2 nitrogen on the right. We have 6 hydrogen on the left, 6 hydrogen on the right. 3 copper on the left, 3 copper on the right, 3 oxygen on the left, 3 oxygen on the right. Our equation is balanced. So you see how I start with one element and then see what the balance is from the left to the right side, and if I make a change by adding a coefficient, how does that affect any other atoms that may be part of that formula? One more problem. Calcium hydroxide combines with hydrobromic acid to yield calcium bromide and water. This is an acid-base reaction, which we'll get to later in the course. And it also, again, has some formulas that you don't know how to write yet, but the day will come. So calcium hydroxide has this formula, CaOH2. This little subscript of the 2 applies to both the oxygen and the hydrogen, so you have to factor it in like you do in algebra. Then hydrobromic acid is just hydrogen bromide in water, and it's going to yield calcium bromide, and I know from my understanding of how molecules are formed that the formula will be CaBr2 and then H2O. So here's our formula. Let's count some atoms. On the left-hand side we have 1 calcium, we have 2 oxygen and 2 hydrogen in our calcium hydroxide, because as I said, you have to take that subscript 2 and factor it into both elements inside your parentheses. We also have 1 more hydrogen over here, plus another hydrogen, so you've got 3 hydrogen altogether on the left-hand side, and then 1 bromine. On the right-hand side, we've got 1 calcium, we have 2 bromine, 2 hydrogen, and 1 oxygen. So where do we start? Well, let's start with one that's not imbalanced. We've got 1 bromine on the left and 2 on the right. That's a pretty easy fix. Let's make this 2 bromine and see what happens. So if we put a 2 coefficient in front, now instead of 1 hydrogen, we have 2 hydrogens, so we actually have 4 hydrogen over here. If we have 4 hydrogen on the left, we need 4 hydrogen on the right. In our water, we only have 2, so we need to put a coefficient of 2 in the front. That will give us 4 hydrogen, but it also gives us 2 oxygen. But look, that's what we want because we have 2 oxygen on the left, and now we have 2 on the right. And we have 1 calcium on the left and 1 on the right. So just with those 2 simple steps, this equation is balanced. Sometimes it might take you a couple times to figure out where to start. If you started working on the oxygen, for example, it might have got confusing. So if it looks like it gets too complicated, start over and pick another element to start with. But basically, begin with your skeleton equation, count atoms, and then add coefficients to balance things. Always, always start with a balanced equation whenever you do any chemistry math. That will become a very important rule as we go on in this course. That finishes what I want to cover in this video.